Today we're going to have a look through the revision questions, topic by topic, so you can go through these steadily and just have a look at what you need to do. The first question here is around index laws and scientific notation and converting it to decimal notation. So there's a variety of ways of looking at this, but probably the easiest way to remember these is that 10 to the 0 equals 1, 10 to the 1 equals 10, 10 squared is 10 by 10 is 100, 10 to the 3 is 1,000, 10 to the 4 is 10,000, and so on. So in this first question, 4.12 by 10 to the 2, 10 to the 2 is 100, so 4.12 by 100 is going to equal 412. And we can just double check this and see, have we moved the decimal place 2 spaces, just like that. We have 1, 2. The next one, 6.1 by 10 to the 4. So 10 to the 2 is 100, 10 to the 3 is 1,000, 10 to the 4 is 10,000. So 6.1 by 10,000 is 61,000. And we can just double check this. We've moved the decimal point. We've moved it 1, 2, 3, 4. That's going to work out very nicely. Now, when we get to the negatives, we're moving in the other direction. We're moving the decimal point in the other direction. In this case, we're going to move it 1 place. So it's going to equal 0.522. Effectively, the decimal point is moved 1 place to the left. In this case, we've got to move the decimal point 4 places. 1, then we're going to have to think of some more zeros, 2, 3, 4. So it's going to be 0. Let's make this the proper size. 0.000112, or just to double check this again, 1, 2, 3, 4 places down there. I'm afraid that should be on the one line, so let's just change that. Okay. Now we're going to go the other way. So that's going from scientific notation into decimals or large numbers. Now we're going to go the other way. How do we turn a number into scientific notation? Well, we start by always making the decimal place after the first digit. So it's always going to be 3.4 by 10. In this case, it's just actually 3.5 by 10, which is the same as saying it's 10 to the 1. Next one, we're going to have to move the decimal point a few more places. It's going to be 1, 2, 3, 4. So it's going to be 3.3255 by 10 to the 4. And when we talked about that before, we said that 10 to the 4 was 10,000, so it should be 3.3255 by 10,000. So it should give us 33,000, and we can look and check back and see that is the case. 0.4, how many places have we got to make this a decimal? 1 and 2. So it's going to be 4.0 by 10 to the minus 2, because we've started as a decimal. Another way we can think about it, the negative 1 column is tenths, the negative 2 column is hundredths. So we've got 4 in the hundredths columns there. Here we've got to go a little bit further. We've got 1, 2, 3, 4 different ones. So it's going to equal 4.0 by 10 to the minus 4. Now we introduce the idea of significant figures. And what we want to do with significant figures is we want to count the number of numbers after the first number, 1, 2, 3. So this is the one we want to make sure it's correct. And now we've just got to make the decision, does the fourth number, the next one, do we have to round up or not? And in this case, because it's 5, if it's 5 or higher, we round up. So we've got 1,350 to 3 significant figures. So if we want to write that, it's 1.35 by 10. And if we want to check the number of places, we've got to move it 1, 2, 3 by 10 to the 3. Or we may just remember that this is in the thousandths column, the thousandths is 10 to the 3. So the only thing we've done is we've gone to the third figure down, 1, 2, 3, and we have rounded that up because it's the third significant figure. In this case, let's go to the third significant figure. The 5 is the first significant figure, second, third. The 4 is after, so we don't have to round up at all. We're in the hundredths, so 1, 2, so it's going to be 10 to the minus 2. So it's 5.12 by 10 to the minus 2. In this case, we've got much the same thing. 3 significant figures, 1, 2, 3. The number after the third significant figure, the number after the 2 is a 6. This time we have to round up. It's going to be 5.13 by 10 to the minus 2 again. And I've asked in the next question to say, well, why are these two slightly different? And it's because of the rounding we've done to make it correct to 3 significant figures. So let's go to the next topic, which is algebra. Okay, and we're talking about some worded problems in algebra. Amy had 11 less shots during her round of golf than Scott. How many shots did Amy have if Scott had 87 shots? So let's put the answer here next to us. Amy's going to have 11 shots less. So we could represent that as Scott minus 11 equals Amy's. So in this case, Scott had 87 minus 11 equals Amy, and 87 minus 11 is 76. So Amy had 76 shots. The next one, Scott has 92 shots. So we've said that the rule is always going to be that Amy has 11 less than that. So here it's going to be 92. I'm not sure what's going to a different line, but let's just follow along anyway. 92 minus 11, and that equals 81 shots. So probably should write our units in here as well, just to be as clear as we can about our answers. And then the third one, Scott has X shots. So in this case, if Scott has X shots, Amy's going to have 11 less. So Amy is going to equal Scott minus 11. And you might write that as just the first letter, A equals S minus 11, as a way of representing an A equals Amy and S equals Scott. So that's that first worded problem there for algebra. The next question we've got, and I've just got to change this, so this was a bit of a messy question. Bruce spent 5 hours listening to One Direction yesterday. How long will he spend listening to One Direction today? Okay. If he listened to 2 hours more than he listened to yesterday, well, he listened to 5 yesterday. It's going to be 5 plus 2, which equals 7. The second one, 1 hour less than he listened to yesterday. It's going to be 5 hours yesterday minus 1, which equals 6. X hours more than he listened to yesterday. So it's going to be, yesterday was 5 plus X. And the last one, W hours less than he listened to yesterday. It's going to be 5 minus W. And that gives us the expressions there. Okay, the next one. John gets X dollars for every shirt he irons. How much money will he receive if he irons Z shirts? So let's let money equal M. And if you think about this, logically, he's going to get X dollars multiplied by the number of shirts he irons. It's a little bit like saying if he was given $5 for each shirt, he irons 10 shirts. He's going to get 5 times 10 is 50. In this case, the money is going to equal, we might set up the other ones as well. We'll say S equals number of shirts, and A equals the amount per shirt. So this will just be that the money he receives is going to equal the X dollars that he gets multiplied by the Z shirts. So it's just going to be X times Z, or we often write that as XZ. And look, I probably didn't need to put these things in here because we had already been given that there was X dollars and Z shirts there.